In this video, I'm going over the first lesson on the imaginary number or imaginary unit, and we'll also talk about the powers of I. So as we get to the imaginary and raising it to an exponent. So these were just some review questions though, on simplifying radicals. So if you want to go ahead and pause the video and try these three on your own. And here we go. So you could go the option of, so like for example, prime factorization, right? So I could, let's say, for example, break down 50 into 10 times 5, right? Or the radicals. Then notice how we do have a prime number here, so radical 5. But radical 10 can be broken down even more to 5 and 2. Then I'll cross that out. So now notice here, we have all our prime numbers here. Notice how you have a pair of 5s. So that's what you take out, making this 5 radical 2. Now, another option is you have radical 50 and then focus on the perfect square factors. So like, for example, here, oops, sorry. So like here, you could focus on prime perfect squares. So here, what is a perfect square factor of 50? Well, 25. So 25 times 2. So now what is the square root of 25? Well, the square root of 25 is 5. So I could say that this is 5 radical 2. So notice how here you end up with the same solution. So again, you could focus on prime factorization or you could focus on the perfect square factors here. So like for example, I'll just focus on perfect square factors. So here, 45. What's a perfect square factor? 9 and 5. So the square root of 9. So here you have square root of 9 times radical 5. So here we've got radical 9, radical 5, and radical 9 or square root of 9 is 3. So 3 radical 5. So then here, 48. Well, here, perfect square factor is 16. So I could state radical 16 and radical 3. The square root of 16 is 4, so 4 radical 3. We're also reviewing here solving our quadratic equations. So go ahead and pause the video and then we'll talk about how these graphs also represent these equations. So go ahead and pause the video and try these three on your own, solving for x. And here we go. So like notice here how the first one is, we are adding 1. So we would then subtract 1 from both sides, leaving us with x squared is equal to 9. Then take the square root because you're solving a quadratic here. So take the square root of both sides and you get x is equal to plus minus 3. So that means that's how we end up with the two solutions. So here, that's how you end up with. So these two solutions for our graph here are -3 and +3. So then same thing here. This graph represents this equation here. Same equation. We would subtract 1. You end up with x squared is equal to 7. Then what would we do? Take the square root. So I've got the square root, which is x is equal to plus or minus radical 7. So this point here is negative radical 7, and this point here is the positive radical 7. And so now the last one is the most important one, what we're talking about today. Because here you would subtract 1, right, from both sides. Now notice how you have x squared is equal to -1. Now let's just say you take the square root. Well, what happens if you try to take the square root of -1? You're going to end up with like an error message on your calculator, right? Because you can't take the square root of a negative value. Notice how this graph here too, where is it crossing? Is it crossing the x-axis to show our x-intercepts? Well, no, it's above, meaning that this has no solution. So notice how here, this is our no solution. These had two solutions, and here we have no solution because it's not crossing the x, because notice how you end up taking the square root of a negative. So again, there are none. There are no real solutions. So this is now what we're focusing on here in our new unit. We are focusing on what's called the imaginary unit, which is the square root of -1. That's our unit. And we're going to represent the square root of -1 as I. So like, for example, again, right? Technically, if I wanted to solve for I here, I squared, you take the square root. So I is equal to the square root of -1, or I squared is equal to -1. This is what we're now focusing on. So like now here, for example, if we wanted to go with like higher powers, right? So like I to the 0, well, anything to the 0 power is just 1. So even x to the 0, y to the 0, -300 to the 0. Even I, the imaginary unit, to the 0 is 1. We just talked about I to the 1, because remember, I to the 1 is just I. Well, what's I? Negative square root of -1. So here, I to the 1 is just I. Now, I squared. Well, I squared is now -1. Now, I to the third. Well, I to the third, well, that is I squared times I to the first, right? If I wanted to break it apart. Well, what's I squared? I squared is -1 times, well, what's I to the first? Well, I to the first was just I. So that means if I've got -1 times I, this is -I. Now, I to the fourth. Well, that is I squared and I squared. So I squared times I squared. Well, that's -1 times -1, which is +1. So notice from our table here, right? The first powers of I are 1, I, -1, -I, back to 1. So I to the fifth, well, guess what that's going to be? I. Then I to the sixth is -1. I to the seventh is -I. Then guess what I to the eighth is now going to be? Back to +1. I to the ninth is I. So what is the pattern? The pattern is you start at the number 1, then I, then -1, then -I, back to 1. So there is what we call a quarter method. So a quarter method is we're going to divide by, well, how many quarters are in a dollar? Well, there's 4. So we're going to divide our exponent by 4 and use this as our pattern. If you have 0, it's 1. So an exponent of 0, with 0, you end up with 1. 1 quarter is I. 2 quarters is -1. 3 quarters is -I. That is our pattern here. So like, for example, I could take I to the 99. We're going to use our quarter method and divide by 4. So here we've got 99 divided by 4, which gives us 24.75. Now, we don't want to focus on the 24. We want to focus on the quarters, which is 75 cents. Well, how many quarters is 75 cents? Well, 75 cents is 3 quarters. So if this is 3/4, then I to the 99th is the same as I to the third power. Oops, sorry about that. I to the third power. So I to the third power, go back to the pattern, right? Anything with the third power is negative I. So then here, again, we're going to take the exponent of 17, right? And we're going to divide by 4. So 17 divided by 4 is, you get 4.25. Well, how many quarters is, sorry about that. How many quarters is 25 cents? Well, that's just 1/4. So I to the first power. So that means now, what was I to the first power? Well, I to the first power is just I. So notice how here we're dividing by 4. Now this one's a little different because you have a coefficient of 4. So in the end, we're going to multiply by 4, but here we go. We're going to take that exponent, divide by 4, right? Now when you divide by 4, you end up with a whole number of 30. No quarters, right? Nothing. This is 0. So we're going to bring down the 4 times. But now this is I to the 0, because there was nothing left here. So this is 4 times. Well, what's I to the 0? Well, that's just 1. What's 4 times 1? 4. So 4 times I to the 120th power is just 4. So we're going to do the last one here. So again, you're going to take the exponent, right? You're going to divide by 4. So here you get 16,000, but 0.5. So how many quarters is 0.5? 2. So we're going to bring down that coefficient of -2 times, now I to the second power. So here we go. Well, -2 times, well, what is I to the second power? -1. So now we solve. Well, what's -2 times -1? +2. So go ahead and pause the video now and try these 4 U-tries on your own. And here we go. So for the first one here, when you divide it by 4, you get 3.5. Well, 0.5 is 2/4. So that's I to the second power, which is just -1. So here for the first one, you should have just gotten -1. Now, when you divide 64 by 4, you get a whole number of 16, right? There was nothing. So this is I to the 0. And I to the 0, anything to the 0 power is 1. Then here you have 18. So 18 times. When you divide it by 7 by 4, you get 1.75, which is 3/4. 0.75, 75 cents. So I to the third power. So this is 18 times. Well, I to the third power is -I. So now 18 times -I is -18I. So then the last one here, when you divide 41 by 4, you get 10.25, which is 1/4. So bring down the coefficient, -6 times I to the first power, because you had 1/4. So -6 times I, which is -6 I.